Hi there, and welcome to this lesson on Pure Mathematics 4. And in this lesson, we're on Chapter 6, 6.7, Modeling with Differential Equations. Now, what this section deals with is very practical questions where you have to apply a lot of the techniques that we've learned throughout Chapter 6. We'll go straight into an example. Example 1. A liquid cools at a rate which is proportional to its temperature, T degrees C, at a time T minutes. Initially, the temperature of the liquid is 100 degrees centigrade. Show that T, the temperature, equals 100 e to the minus bt, where b is a positive constant. Now, these questions, frequently the most difficult thing to do is get started and find the right way into the question. And you need to look very carefully at what they've told you in the question and what the things mean. And you need to work out for yourself a differential equation. So they haven't given you a differential equation to solve, but they've given you enough information for you to create a differential equation and then solve it. The way we do it on this question is consider what they're telling us. And what they're telling us is the rate at which the temperature of this liquid is cooling. Now, the rate at which the temperature is cooling will be dt dt, where the big T is the temperature and the small t is the time. Now, you'd need to know that that's what the differential means. So dt by dt is the rate of change of big T with respect to small t. So it's the rate at which the temperature is cooling. What we're told is that is proportional to the temperature. So the rate of change of the temperature, dt by dt, is proportional to the temperature, big T. They tell us that in the question. And then the next thing you'd need to know is that if something is proportional to something else, that means it's equal to a constant times by that thing. So dt by dt will equal a constant times by big T, the temperature. Now, I've chosen to call that constant minus b. And the reason why I've chosen the minus is it's normal to do that in this type of question because the temperature is decreasing. So the minus really implies that you have a decreasing temperature. If you had water that you was heating up and it was getting hotter and hotter, then you wouldn't need the minus. You'd just say BT. But what we have here is a differential equation. And we can solve this by separating the variables. So separating the variables in this differential equation will give us the integral of 1 over big T with respect to t is equal to the integral of the constant minus b with respect to small t. That's where really the hard work is in this question, getting to this point. But from here on, all you have to do is use standard techniques to solve these two integrals. I'll let you have a go at doing that. So pause the video and see if you can work your way through this. Okay, let's have a look. Integrating the left-hand side just gives us the log of big T. Integrating this constant minus b with respect to little t will give us minus bt, plus some arbitrary constant. Now, that is the differential equation solved, but we've been asked to show that it can be written in this form, t equals 100 e to the minus bt. So we've still got quite a bit of work to do to rewrite this in that form. To get t on its own, it's a standard technique. We need to cancel out the ln, and the way we do that is by doing e to the power of both sides. So e to the power of log t on the left-hand side will just give us t, and on the right-hand side, we'll have e to the power of minus bt plus c. As we've done before, we'll now separate out this constant e to the c, so that we get e to the c times by e to the minus bt, and I'll choose to rewrite that constant as a, which is itself a constant. We're very close to the answer now. All we need to do now is show that a is equal to 100. And the way we'll do that is by using the initial conditions given in the question. So we are told in the question, initially, the temperature of the liquid is 100 degrees centigrade. Initially means when the time is equal to 0. So that's saying that when t is equal to 0, when the time is 0 minutes, the temperature will equal 100 degrees centigrade. We just have to substitute both of those values into this equation. And that'll give us 100 equals a times by 1, e to the power of 0 is 1, which means that a is equal to 100. And that gives us the solution we were trying to get. T is equal to 100, e to the minus bt. Now, at this point here, you may well have chosen to use a different letter than b. If you did, you'll have a different letter here, but that wouldn't be a problem. Okay, part 2. Given that the temperature is 50 degrees centigrade, when the time is equal to 8 minutes, show that this constant here, b, is equal to 1/8 log 2. So we're going to have to substitute 50 into this equation and 8 for little t, and then solve that equation to find the value of b. Again, it takes a little bit of work, this, but I'll let you have a go yourself first. So pause the video, see if you can do it, and come back to me when you're ready. Okay, let's have a look. So that's the equation that we have, and we're substituting in t equals 50, the temperature is 50 degrees centigrade, and little t is 8 minutes. Dividing by 100 gives us a half is equal to e to the minus 8b. Now, in order to solve this equation, we need to take log of both sides. It's the standard method for solving an equation where the power is the unknown. And given that we have e here, then we'll do ln of both sides. And that gives us log of a half, and the ln and the e cancel each other out. And that gives us minus 8b here. We'll do a little bit of work with this half. The half is 2 to the power of minus 1. And then the log of 2 to the power of minus 1 is the same thing as minus 1 times by log 2. And the reason why we've had to do all of that work is if you look at what they've asked us to show in the question, they've asked us to show that b is equal to 1/8 log 2. So we needed to rewrite this in terms of log 2. Now we can just write down the answer. Moving the minus 8 to the other side gives us b is equal to 1/8 log 2, which is what we were asked to show. Okay, that's what we've done so far. And then part 3 asks us to calculate the time at which the temperature will reach 20 degrees centigrade. So big T here is going to be 20. B we've worked out already is equal to 1/8 log 2, so we'll substitute that in. And then again, we'll have quite a tricky little equation to solve, but I'll let you have a go at doing that. So substitute in T equals 20 and the value of B, and try and solve the equation. Pause the video, come back to me when you're ready. Okay, let's have a look. So here we've substituted in the value of B, 1/8 log 2. And here we've substituted in the temperature that we're interested in. We want to know when the temperature will be 20 degrees centigrade. And now we need to solve that. Dividing by 100 gives us 0.2 on the left-hand side. And here we're using a power rule. You've got e to the 1/8 t times by log 2. Using the rule for powers, that's the same thing as e to the power of log 2 all to the power of minus 1/8 t. And the reason for writing it in that form is we can then cancel the e and the log here. So on the left-hand side, we'll have 0.2. The e and the log cancel each other out, and we've just got 2 to the power of minus 1/8 t. Still a little bit of work to do. We've got an equation to solve where the variable is the power. And the method for solving such equations is to use logs. So we go back into logs again and say the log of 0.2 will equal the log of the right-hand side. And then this power, minus 1/8 t, will come down to the front using the rule for logarithms and powers. Then moving the log 2 to the other side, we'll have minus 1/8 t is equal to log 0.2 divided by log 2. And solving that gives us t is equal to minus 8 times by this. And all of that you put into the calculator. When you put all of that into the calculator, to the nearest minute, you get 19 minutes for the answer. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 90 and have a go at exercise 6G. Thank you very much for listening.